Welcome to GRADS COMPEER. Let us solve another numerical problem. Let us read the question carefully. This question has two parts. First question, find the x and y components of forces P and T with respect to the given axis. Second question, find the magnitude of force Q and its angle of inclination whose x and y components are shown in the figure below. So in the first part of the question, two forces are there, force P and T, for which we need to find their components. And second part of the question, the components of the force are given and we need to find the magnitude of the force and its inclination theta with respect to the given axis. So let us try to find the components of force P first. In order to find the components, first we need to draw the directions of the components. Second, we need to find the angle which the force makes with its x component or the x-axis. So the x component is drawn parallel to x-axis and the y component is drawn parallel to y-axis. Here px is the x component and py is the y component. We can say that px and py are the components of p and p is the resultant of px and py. Now someone may say, what is wrong in drawing the x component in this direction which is also parallel to x-axis and y component in this direction which is also parallel to y-axis? How do we know whether the directions taken are right or wrong? The answer is it has to come from with the parallelogram law. That is, if you draw two lines parallel to x and y axis, it forms like a square or a rectangle and the resultant will be represented by the diagonal. Here we can observe that the resultant that is formed here is in a different direction than the direction of the original force. Therefore, it does not conform with the parallelogram law and the directions of the components that are taken are wrong. So, the directions of the components originally taken are correct because they conform with the parallelogram law. So, we have done the first part, that is to draw the directions of components Px and Py. Now, second thing is to find the angle which the force makes with its x component. Here that angle is given as 60 degrees. Let that angle be theta 1. Whenever the angle between the force and its x component is given, then the x component will be the cos component and y component will be the sin component. Remember that the component adjacent to the given angle will always be the cos component and the other will be the sin component. So px will be equal to p cos theta, p is given as 200 and theta 1 is 60 degrees. Substituting we get 100 Newton. Similarly, py is equal to p sin theta, where p is 200 and theta 1 is 60 degrees and we get py is equal to 173.2 Newton. Observe here that both magnitudes of px and py are positive because they are directed in the positive direction of x and y axis. Now let us say that the angle between the force and the y component is given. Now if theta is 60 degrees, 90 minus 60 is 30 degrees. So if the angle between the force and y component is given, which is 30 degrees in this case, then the vertical component which is adjacent to the given angle will become the cos component and the other component will become the sin component. So px will be equal to p sin theta 2, where p is 200 and theta 2 is 30 degrees. Again we will get the same answer, that is 100 Newton. And py is equal to p cos theta. Here also we will get the same answer, 173.2 Newton. Now let us find the components of force T. Draw the x component parallel to x-axis and y component parallel to y-axis. Observe here that the directions of the components are drawn correct because they conform with the parallelogram law. So once we have indicated the directions of components, next thing is to find the angle theta which the force makes with its x component. Now here the angle between the force and its x component is not given. Let that angle be theta 2. The angle is not given but the slope of the force is given as 2 horizontal and 3 vertical. If we consider that slope triangle where x is 2 units and y is 3 units and the length of the hypotenuse is d. From this slope triangle we can find the angle theta 2 by taking tan theta. Tan theta is equal to opposite side by adjacent side. Opposite side is 3, adjacent side is 2. So tan theta is equal to 3 divided by 2. So theta 2 we get it as 56.3 degrees. So once we get the angle between the force and the x component, we can find the horizontal component tx is equal to t cos theta and ty is equal to t sin theta. Substituting t is equal to 722 which is given and theta 2 that we got 56.3 degrees, we get tx is equal to minus 400 Newton and ty is equal to plus 600 Newton. Observe here that Tx is negative because it is in the negative direction of x-axis, and Ty is positive because it is in the positive direction of y-axis. There is another way to find the components of force T without finding the angle theta too. That is by using the slope triangle. For that, first we need to find the length of the hypotenuse D, which is equal to root of x square plus y square. Equating x equal to 2 and y equal to 3, we get D is equal to 3.6 units. This slope triangle will be in proportion with the force triangle. The x and y are called the distance components and Tx and Ty are called the force components. X and y are the distance components of D. Tx and Ty are called the force components of T. Now the distance components and force components will be in proportion, and that proportion is represented as a ratio force component Tx by distance component x equal to force component Ty by distance component y equal to force divided by distance. Substituting x equal to 2, y equal to 3, T is equal to 722 and D equal to 3.6, and solving this equation, we get Tx equal to 401 Newton and Ty equal to 601 Newton. These magnitudes are slightly greater than the magnitudes that we got by the previous method, just by 1 Newton, but that is okay. Now let us solve the second part of the question. The magnitudes of the components of force Q are given, Qx and Qy, and we need to find the magnitude of force Q and also its angle of inclination theta with respect to the given axis. This is very simple. The magnitude of force Q can be obtained from Q is equal to root of Qx square plus Qy square. Substituting the magnitudes of Qx and Qy, we get Q is equal to 400 Newton. Now to find the angle of inclination theta, let us consider the force triangle. From this force triangle, we can take tan theta, which is equal to opposite side by adjacent side. Opposite side is Qy and adjacent side is Qx. So tan theta is equal to mod Qy by Qx. From this we get the value of theta is equal to 35 degrees. Note here that we are taking only the positive magnitudes of the components for calculating the angle theta. Let us try to understand this a little more. One of the methods is to measure the angle with respect to positive x-axis, and we get the angles as positive or negative based on the clockwise or anti-clockwise measurement. The other method is more convenient, where the angle between any given force is measured with respect to positive or negative x-axis based on the quadrant in which the force is situated. Hence the angle theta that we obtain here is always positive. There is no negative convention. For this, we always consider positive magnitudes of the components while calculating the angle theta from this equation. So that's all in this video. Thanks for watching. See you in my next video.